Hello everyone, welcome to this course on square root decomposition. So in this course we are going to talk about square root decomposition and what are the various problems that you can solve using square root decomposition, what is an MO algorithm and a lot of more techniques regarding the square root decomposition. So we will be solving quite a lot of problems. So I expect you to watch this entire course in order and only skip topics if you are aware of these techniques beforehand. Otherwise, just follow through the videos and you will understand with a lot of clarity about what square root decomposition is. So, moving forward, let's begin with what decomposition means and why do we call this a square root decomposition technique, right? So, first of all, this square root decomposition means that, just give me a second. Okay, so square root decomposition is a technique which is used to solve problems, and it is not always applicable. We solve problems of only queries using square root decomposition, which means that only problems wherein you are asked to compute results for each query separately, square root decomposition is going to help you in solving this kind of problems. So basically query related problems. So also, not all query related problems can be solved using square root decomposition. So it is just one of the many techniques that are used to solve these query problems. So starting with what decomposition means, and let us say that we have an array, and in this array we are going to decompose this array into set of segments. So let us say we decompose them into many segments, and each of this segment is called a block. So this is nothing but a block. So decomposition simply means that dividing your array into some blocks, and each block will have a specific size. Let us say that its size is S. Each block will have the same size. So S, and lastly, this can vary. Like this will be S1, not necessarily S, and we will see the reasoning behind that. So now the question is that how many blocks do I have, right? So let us assume that the total number of elements in your array is n, right? So n is the total number of elements in your array, and each block is having size s, right? And how many blocks are there? K blocks are there. Let's ignore this s1 for now. So with that in mind, the number of blocks that you have is nothing but n by s, right? So n by s is the number of blocks that you have, and this last block can be of size s1, right, is not always equal to s. Now let us look at this by an example. So let us say that your n is equal to 7 and your number of elements in each bucket or each block is nothing but 2, right? So how many blocks are you going to have? You're going to have 4 blocks, right? So in first block you will have 2, then 2, then 2, and remaining elements which will be less than equal to, which will always be less than or equal to s, will be placed over here, right? So we can safely say that n modulo s will be the number of elements placed in the last block, and if this is 0 we obviously won't count that as a block, right? So over here we are going to place one element. So in this way we got 7 elements and number of blocks are 4. So you can see that this over here, when we talk about n by s, we actually mean ceiling of n by s. Why? Because over here you say n is 7, s is 2, so ceiling of this will give me 4. Now the question is that why are we dividing this into blocks, and what is this optimal block length, block size, right? How to decide on this s parameter, and why are we dividing this into blocks? So for that comes the other part of the technique, which is called square root. So this means that for most of the cases, it's not always, but for most of the cases, you will divide your blocks into size of square root n. And why is that? So for most of the cases, let us say how many blocks are we going to have? We are going to have k blocks, right? And if we have k number of blocks, then this equation should hold true. And therefore, how many uh, elements we are going to have in each block? We are going to have n by k number of elements in each block. So we are, in most of the cases, we want to minimize this, right? So in most of the cases, this will be the final thing that we want to minimize. So in most of the cases, if we want to minimize this one, we know that the minimum value of this will arise when k is nothing but equal to root n, right? So that you can prove yourself. And then इसलिए therefore the for most of the cases you will have the value of k is equal to root n, and therefore the technique is called square root decomposition, wherein the block size will be nothing but square root n. Alright, and square root n. So now accordingly we will solve a very simple problem in the second part of this video using this technique of dividing the array into blocks and each block having size square root n. And with that technique we will understand why this particular term is important to us, and why we want to minimize this. And let's meet you in the next video.